All right, so I had some requests to go over the virtual LabFlow Equilibrium Lab. And so I wanted to talk a little bit about what's going on and, of course, how to handle the calculations in that. So I created the slideshow, and this is posted in the announcement section on Canvas. So this is the reaction that they give you. And when you have a lot of organic-y things, having all of these letters here makes it kind of hard to figure out what's going on because they all kind of end up looking the same. So I'm going to change my abbreviations here. So the first one is ethanol. And a lot of times we will abbreviate ethanol as ETOH and methanol as MEOH. The OH is what makes it an alcohol. And so that's going to help us to keep it separate from acetic acid. So I've got that as ACAC. Now, in the directions, they say they're using glacial acetic acid, which is essentially pure acetic acid, that meaning there's no water molecules in there at all. So when we do this reaction, any water that is produced is actually a product of the reaction. It's not a solvent the way it would be in a lot of the labs that we do. And then for our products, we have ethyl acetate, which I'm abbreviating as EA, and water, which I'll just leave as H2O. So when we start out the reaction, we are told that we're initially starting out with 0.5 moles of ethanol and 0.5 moles of the acetic acid. And so this means that we have exactly the same number of moles of each. Now, the equation is balanced as written, so there's a 1-to-1 ratio between each reactant and each product. And so that means that every time we lose one part of the acetic acid, we're going to lose exactly that same amount of the ethanol, and we're going to create exactly that same amount of both the ethyl acetate and the water. And this is important to remember when you're trying to come up with the concentrations of things beyond the acetic acid. All right, so we're going to call the concentration for acetic acid A initially. And that's the first thing that you're going to end up calculating is that initial concentration. So what you want to do is set up what's called an ICE table. If you haven't gotten to this in class, sometimes it's referred to as a reaction table. And the point of this is to help you sort out what is going to be your initial concentrations, what's happening in equilibrium, and help you to find what you're looking for. So initially we have that concentration A of the ethanol and the acetic acid. Remember, they both have the same number of moles, and they're both creating the same volume. So whatever that volume is, they have the same molarity there. And then because it's initial, we don't have any products yet. And so there's no ethyl acetate and no water. So every time there's a change, it affects each of these the same way. Now, if I had coefficients, I would be using those coefficients here. But in this case, I'm losing X, whatever that amount is, of each of the ethanol and the acetic acid. So suppose I had a coefficient of 2 in front of the ethanol, then I would put minus 2x instead of just minus x. But in this case, all of our coefficients are 1, so we're just doing minus x. And then every time we lose these, we're gaining the products, and so those are plus x. And then to get to our third line, we're just going to add the first two lines together. So for our reactants, that means each of them is going to be A minus X, and each of our products is just going to be X. And so when you're doing your calculations of the equilibrium concentrations, you should have the same number for the ethanol and the acetic acid, and you should have a different number, but the same as each other for the ethyl acetate and the water. Okay, so we're a little bit complicated with the sulfuric acid because, of course, in adding sulfuric acid to what's going on here, this is going to react with the sodium hydroxide, the NaOH. So what we have to do is figure out how much of the NaOH is reacting with the sulfuric acid. And since it's a strong acid, we can kind of think of that as reacting with that first. And then we can determine that everything else is reacting with the acetic acid. So we go through, they give you the information on how much was used in the blank So the blank is what is used with the sulfuric acid. And whatever that volume is, we're going to subtract it from the amount that is used for the equilibrium calculation. So if we used 13 milliliters total at equilibrium, but we know that the blank takes 4 milliliters, we would subtract those two and say we need 9 milliliters of the acetic acid. All right, so in doing the calculations, first you want to think about whether you're talking about molarity, which is a concentration, or moles. And remember that our reactions happen with equivalent moles. So if we wanted to find the moles of the sodium hydroxide, the NaOH, we would take the concentration that is given, I think it's 0.25, and the volume that is given and multiply them by each other. Now, technically, we would need to put this in liters, but because all of the volumes are in milliliters, all of that exchange between liters and milliliters is going to cancel out. So it's fine, really, if you just leave it in milliliters. But in order to determine the moles of that, we would do molarity times volume. And this is also going to be true for the acetic acid. Now, when we test it, we're not testing the whole volume, we're testing 1 milliliter. And pipettes can be very, very precise. So what we're going to end up doing is having the acid volume be 1 milliliter, the base volume be whatever it is they tell you. That might be 10 milliliters, that might be 13 milliliters, whatever they tell you. And the molarity will be for the base, I think it's the 0.25. And so you'll just plug in all of these numbers and solve for the acid concentration or the acetic acid concentration. All right, so that's kind of the basic idea of how you're going to do the calculations, and hopefully that helps you to complete the Equilibrium Lab.